Hello. You all right? Boost Camp 2025, eh? Bring it on. I've watched from the sidelines for the past 2 years. I was invited last year. Thank you for the invite. But genuinely, as someone who puts on some conferences or have done in the past, Boost Camp has always been the one that I kind of look at and I think, I wish I'd organised that one. It's always really, really good, great atmosphere, great speakers. And Jerry teed it up brilliantly there in terms of the need for clarity. And I think it's commendable to Boost to do something like this, because even me, I spend all day, every day, just consuming and creating, and everything's revolving around AI, and even I get confused. So I wanted to start with a little clip, as you do, from Enter the Dragon. Bruce Lee. Any Bruce Lee fans out there? Yeah, just one at the back. Brilliant, yeah, childhood well spent. So this clip is from Enter the Dragon. Obviously, you probably haven't seen it, seeing as though there's hardly any Bruce Lee fans in here. It means absolutely nothing to you, probably. But this scene is from the end of the film, where Bruce Lee, he goes and he fights like the big boss fella at the end. And this is what happens. So he walks in this room, and you can see that this room is just full of mirrors. Right? And the thing is that he doesn't really know where the bad guy is, because he can't see, because there's mirrors everywhere. So he's thinking, is he behind this cloak? Is he there? Wait for it. No, he's not there. So he turns round. I'll fast forward this bit because it's a bit boring, it gets a bit long. But anyway, you can see that the bad guy is in there somewhere, right? He is in there. But the thing with Bruce Lee is that he can't see where the bad guy is because everything's reflected back at him. But the bad guy hits him in the face because it's his room, he knows where he is. Now Bruce Lee's swinging because he can't tell the difference between what the illusion is created by the mirrors and what the reality is, which is the guy that's actually in there, so he gets confused. So this time he walks down here, he thinks, I wonder if he's down here. But the bad guy, being his room, he just comes up behind him, gives him a little, nice, yeah, there you go, you see. So Bruce Lee still doesn't know where he is, he's getting confused. But then he realizes, if I smash all the mirrors, I'll be able to see the difference between the smashed mirrors and the person, right? So he goes through this bit of a rampage, tries to isolate the person, and you can tell it worked because the music's changed, right? So he finally finds him right at the very end. I'll get out of the way so you get a good view, and he gives him a big kick, and that's it. He kills him, basically. Now, I know what you're thinking, that was a bit of an anticlimax. All that big, massive build-up for one kick, and that's game over. But I was thinking about this film, as I do when I go to sleep at night. And I was thinking, it's very similar to how I feel sometimes and how you might feel when it comes to AI. So every time you wake up, you open your phone, you're looking at LinkedIn, Instagram, X, wherever you get your kind of news from, and all that's reflected back at you is AI. AI. I don't know whether it's because the algorithms are super optimized to my tasting or whether you feel the same way, but it seems to be absolutely everywhere. The other morning, not that I watch Lorraine Kelly, any Lorraine Kelly fans in here? I don't particularly watch Lorraine Kelly. For those that don't know, Lorraine Kelly, little Scottish woman, classic, TV presenter in the UK. She has this morning show where she interviews like A, B, well, more like C and D list celebrities about their latest cookery show or reality TV program. Anyway, it's on in the background, and I turn around and there's a big sign on morning TV saying AI Week. And I think, right, now I know that it's reached mainstream. If it's on Lorraine Kelly, it's mainstream. And if my mum's texted me, which she does sometimes, with prompt hacks, then you know that AI has reached the absolute mainstream. But the problem is, it's a bit like Bruce Lee. You can't see the reality from the illusion, because everything you see and read is all about AI is the best thing since sliced bread. And then you look around and next time it's like, well, AI is the biggest danger to humanity. AI is going to create more productivity in the workplace than you could ever imagine, but at the same time, it's going to cut half of your staff and you're going to have no people left. So it's like, where do you actually trust and where is the value? And it's very difficult to find. So what I'm going to do today is pretend to be Bruce Lee. I've got my ninja trousers on, right? So I'm going to smash a few mirrors that we may see and hear and read about as being fact when it comes to AI, but in actual fact, when you peel back the layers, there's a lot more to it. So hopefully over the next 20 minutes or so, we will together find some clarity. Now, firstly, we have to start with how impressive these technologies are. You can't really hide. That video at the beginning that was shown with Mark Zuckerberg and all these people who are saying AI agents are going to be everywhere and AI agents of the future, maybe, but the thing that you can't avoid is how impressive these models are. So this chart here from Epoch AI is showing how much training data some of the biggest models have. And if you look at DeepSeek, GPT-4, Llama, they have 10 trillion tokens worth of training data. Now, for those who don't know, a token, think of a token as like a small word, or if it's a longer word, it might break up into like 2 or 3 or maybe even 4 tokens. But needless to say, there's still trillions and trillions of words in these models, which is why they're so impressive. They reckon that we might actually run out of training data for these AI models as soon as 2026. And if it's not 2026, it might be 2032. It's costing, how much do you reckon it costs to train one of these AI models? Any ideas? Don't all shout at the same time, I won't be able to hear you all. $100 million is the alleged cost of training GPT-4. The Anthropic CEO reckons that by the end of this year, training costs to train an AI model is going to reach around about $1 billion. $1 billion, it's absolutely crazy. And that means because there's so much data, it requires, and all these models require so much compute to train the models and to run the models that it's absolutely staggering. These numbers are absolutely staggering, right? If you look at the pink dots here, these pink dots are all of the like industry models, the commercial models that are created by private organizations. And on the right-hand side here, this is training compute. It's measured in petaflops. I'm sure you all know what petaflops are, because I absolutely do. It's essentially, a petaflop is a way of measuring compute, right? It's a kind of, one petaflop, for example, is the equivalent of 1 quadrillion computing operations. 1 quadrillion, and that's per second, which means that 1 petaflop day is the equivalent to 1 quadrillion processing operations every second, all day for 24 hours. That's 86,400 quadrillion processing operations. To train these models, it takes 10 billion petaflop days. That's 1 quadrillion processing operations per second, all day, every day, for 10 billion days. It's absolutely mind-blowing how much compute goes into these models. Now, it's not one computer that does this, obviously, because we'll be here till the end of time waiting for it to train these models. It's a lots and lots of computers running concurrently, but that's why it takes so long, and that's why governments across the world are all funding big, massive data centers in America and China and Europe. They're all funding these big data centers. And it's because it takes so much energy and computing power to train these models. And you think, well, if there's that much money that goes into it, if there's that much computing resource and that much data that goes into it, then these models must be absolutely fantastic. Because you hear, you know, Mark Zuckerberg and Sam Altman and everyone's talking about how great they are. They must be brilliant. And they are getting a lot better. Now, this chart here shows there's a bunch of different benchmark tests that they use to grade how good these models are, and they're listed down here at the bottom. But you can see here, for example, this black one here is PhD level science questions. Now, AI in 2024 passed the human benchmark for PhD science questions. Mathematics, same thing, 2024, very, very close to human. In fact, actually, no, mathematics, it passed human level in 2023. And so you can just see that generally all these benchmark studies are showing that the AI models are getting better at humans in most areas. There's another benchmark, which is called the Massive Multidiscipline Multimodal Understanding and Reasoning Benchmark. Bit of a mouthful. It's essentially a very complex benchmarking assessment. The humans score, on average, the best humans in the world will score 82.6% on this test, and OpenAI's O1 reasoning model scored 78.2. It's very, very close to human-level reasoning or human-level performance. And that's kind of the basis for most of the rhetoric around why AI is so powerful. But the problem is, you don't live in a world of benchmarks, and hardly anybody does. So if the models are so good, then why is it that only 80% or to 90% of AI projects actually make it, or don't make it, rather? Rand found that 80% to 90% of AI projects fail. So why is that? Why, if the technology is so good, if there's so much data, if there's so much compute required and so much money spent on it, if the reasoning and the benchmarks are getting better and better, why is it that businesses are failing to deploy it successfully? And the reason is because it's not necessarily just about the models. There's a lot of other things that are required to go into these things to make them work in your organization. You need data, you need knowledge to fuel the models, you need connectivity into your line of business systems, you need effective processes. You know, you would call it slapping lipstick on a pig, which is trying to automate the things that are already broken in your organization. If you've got a process and it's already broken, the technology that underpinned it's a load of rubbish and you've had it for 25 years, and then you try and stick generative AI on top, inevitably you're going to end up having a very hard time making it work. And also, there's a real illusion at the moment, which is because everyone has access to these models and everyone has access to the APIs, it's very easy to create a prototype. Very easy. You can go onto, you know, any kind of application. There's loads of low-code kind of things out there, and you can build a prototype in minutes. But getting from prototype to testing to production grade is a totally different story. And so there's a lot of people who have the illusion, again, of these things being really easy to use and easy to work with, but it only is easy to do when it gets to a prototyping stage. A lot of companies also try and solve the wrong problem. We've seen lots of examples of businesses where they have really good self-service journeys online and in the mobile app, and they try and rebuild it all with so much complexity in the voice channel, for example, and they might be better off initially just trying to get more traffic into the mobile app and the website because it already works really, really well. So there's a lot of people trying to solve the wrong problem with the wrong technology. And the other thing is that people just want to use it because it's cool. Jerry, as you mentioned, you know, it's a C-level conversation now. And so the board and the C-level is like, right, we need ChatGPT, we need a chatbot. It's a bit like social media in 2006 or whatever. We need a Facebook page. And that's kind of the starting point for it all rather than what problems are we seeking to solve. And so, having said that, as I mentioned, there are lots of capabilities in these models, and every single week there are new models coming out, and there are new benchmark assessments. There's all this kind of action and traction in this space. And Apple released a paper either last week or the week before, really, really interesting paper, and it was assessing how good these models are at reasoning. Now, for a business like yours, reasoning, you could see how there is so much potential if you can have an AI model that can reason. Because if you think about imagine just giving AI all the data that you have about a customer and all the data that you have about your processes and all of the API accesses that you need to all your line of business systems, and you have a customer having a conversation with it, you would think that in an ideal kind of world, the AI could reason through all of that to help the customer get to where they need to be. And it depends on how complex that reasoning requirement is, because what this paper found is that for low-level complexity tasks, the standard models actually perform better than the reasoning models. So all of the kind of like fanfare around these reasoning models that you'll hear, and Sam Altman and everyone is kind of like claiming that AGI is close because these reasoning models are getting better and better and better. In actual fact, for moderate to low complexity tasks, they're not very good at all. And for most of your use cases, especially, for example, if you're automating a process in Boost, for example, you're going to want to explain what that process is. You're going to give access to specific tools and specific knowledge, and you want to give that system a goal. And so you're already setting the boundaries from within which it needs to operate. You don't necessarily need all of these big, high, advanced reasoning models. I think you'll probably find that some of the standard models that exist probably do most of what you need them to do. They found that medium complexity tasks, the reasoning models are reasonable, but high complexity tasks, they all just completely break down. So in terms of finding clarity, the clarity to take away from this is that these reasoning models, they're not yet ready for highly complex reasoning around the kind of things that you might want them to do. If your requirements are kind of lower complexity, and I would suggest that for those getting started and beginning to scale, I would suggest that your requirements probably are low complexity. You understand your business process, you understand the tools and the data that you have available. You probably don't need to try and push these models to the edge of the earth. So there was another great study that followed this, coming out probably 2 or 3 weeks before, and it was looking at, do these models think? Because again, that's the kind of thing that you'll hear in the headlines a lot, is that these models can think and they can reason and they can replicate human brain activity. But this study found that in part they can think, but at the same time they don't think in the same way as humans think. There's some things that they do pretty well, and there's some things that they don't do necessarily well. Now, the things that they do fairly well is grouping concepts and grouping simple concepts. So what's interesting about that is, let's say, for example, you've got an IVR system, you replace that with a voice IVR. So you'll find that these models are pretty good at categorizing kind of basic intents, right? I need to freeze my bank card, I want to change my address, rah, rah, rah. What you'll tend to find is that they aren't always great with dealing with ambiguity. So if something sounds a little bit like something else, then they're not necessarily great at differentiating. They want to categorize everything all together. And so what that means is, in practical terms, using a large language model for an intent classification isn't necessarily a case of just throw everything to the model and it'll handle it itself. You're still going to require some prompting around dealing with that ambiguity and the disambiguation component. It also found that these models prefer compression over detail, which means that they're pretty good at very basic RAG responses, for example, retrieval augmented generation. Ask it a basic question about a policy, and it'll return the answer fairly successfully. But it doesn't necessarily understand, for example, that if I say I want to change my password, and somebody else says, I want to change my password because my ex has access to my account, it doesn't necessarily understand that those two things need to be treated differently. It just wants to compress them both into the same bucket and treat it both like a password reset. And so sometimes that level of detail is required. Typicality weakness means essentially it doesn't understand what a typical representation of something is. It's fairly great at, as I said, grouping concepts in a basic way. So if I was to say, tell me the commonality between a robin and a penguin, you might say that they are both birds, thank you. But if I was to say, what's a better example of a bird, a robin or a penguin, which one do you think is the better example of a bird? Robin, exactly. Robins fly, they build nests, penguins swim, they can't fly, they don't even have any feathers, you know. It's like, so this is the stuff that large language models don't necessarily understand. They don't understand what's typical and what's not typical, which means that they can't necessarily prioritize on their own urgent things versus less urgent things. Now, in CX and customer experience, figuring out what urgency is and what customer problems need to be prioritized over another is quite an important sort of tactic. So without prompting and the efficient or diligent crafting of specific handling for these things, you'll find the models don't necessarily do it themselves. The next thing is context-insensitive representation, which means that they don't always understand context on their own, and especially when context changes the conversation. So, for example, if I was, and I come across this real kind of case study with a German company who was implementing a journey around sales. It was a sales-based journey. They were using retrieval augmented generation. The idea was that you can ask lots of product-based questions, you'll get a lot of answers, and it will help you make a purchasing decision. What it didn't do is it didn't understand what level of intent the customer has. Is this someone who's just kicking the tires and they're never going to buy anything? Or is this someone who's actually showing purchase intent? Because the context of the questions they're asking changes the nature of the conversation. At one point in time, when you can sense, or if it was a human, you'd be able to sense that this person's now interested, I'm going to ask if they want to book an appointment. So context changes the meaning of a conversation, and as standard, these models don't necessarily handle that greatly, which is why you need something like a Boost platform to manage the state, and manage the context, and manage the short-term memory of the conversation, so that you can give the models the ammunition that they need to be helpful. You assume, based on your conversations with ChatGPT, that these models are really good at back and forth conversations. You know, that's kind of like the whole point of a conversational AI system. It should have conversations. The amount of systems that I've seen that actually prove this study out, which shows that actually over time, most of the models, not just these top models, GPT 4.1, Gemini Pro, most LLMs will start to derail after a certain number of turns in the conversation. They're not great at holding conversations. And that's because they're not trained on conversational data necessarily. They're just trained on whatever text they can find on the internet. They don't necessarily understand what a conversation even is. And so they struggle with multi-turn conversations, which again shows you why you need something to manage context and memory and things like that. How human-like these systems are is something that, you know, when you talk to ChatGPT, people think that it sounds human. So there was a study done that was, you know, how human-like are these things? And when they tested GPT-4o and Eliza, in terms of how often a human correctly identified that this thing is an AI, What do you reckon the percentages were for these two models? How often out of 100 do you think a human can correctly spot an AI system generating responses? 40%. All right? For this model, GPT-4o, it was 20%. For Eliza, it was about 25%. They did the same thing with GPT 4.5. This is a model that was released 1 month after Eliza and about 7 months after GPT 4o. They specifically instructed it with a persona. So they said, this is who you are, this is how you should act, this is how you should behave, this is the task that you've got. The difference went all the way to nearly 75%, which means that in 75% of cases, the human couldn't tell the difference between an AI and another human. You might say it's past the Turing test. I wouldn't go as far as to say necessarily that that's the case. But what we can absolutely take away from this is that generative AI can make things sound human. And when we talk about clarity, that if you can take away one thing from this talk, it is that that is where generative AI, for businesses like yours, is really, really good. It can make things sound human. And the reason why it's important to make things sound human is because the only thing that matters is when the customer talks to this system, all you have is the dialogue, all you have is the back and forth. So it needs to feel natural, it needs to be a good experience. We referenced AI agents earlier on. There has been a huge increase in interest in AI agents over the last year. You can see that there's a 1,000% increase. This is Google Trends data. 1,000% increase in people searching for AI agent-related stuff. But as we saw in that video, very few people can define what AI agents are, how they work, how they can be used. And there's a lot of stuff going on that kind of dilutes the meaning of agents and things like that. And so if you look at the textbook definition of an agent, it is a system situated within and part of an environment that senses that environment and acts on it over time in pursuit of its own agenda as so to affect what it senses in the future. This is from Franklin and Gracer. They conducted a really great literature review of all of the definitions of AI agents, and they created this as a synthesis of them all. Can anyone tell me what's wrong with that definition in terms of if you're going to implement a system that meets this definition in your business, is there anything particularly scary or wrong about that definition? Its own agenda. Fantastic. You don't want these systems to have their own agendas, right? You do not want these systems to have their own agendas. You want goal-directed behavior, all right? That means you give it an explicit goal, an explicit task, and you have it perform that task. That means that you're taking away a degree of agency in favor of some control. And you'll see that this is the pattern that emerges as you start to decompose agents into fitting them into an enterprise. You start to de-agentify them in favor of control. And so they need to be goal-directed. The next thing is how it acts. Now, typically, the definition of an agent is that it should pursue its own goals, obviously, which means it needs to kind of devise a plan for how it should approach those things. Now, again, as a business, you don't really want an agent to devise its own plan about how it should resolve a customer query. You've got processes, you've got policies, you've got systems, you've got data, you've got requirements that need to happen in order to fulfill that. So what you want is explicit instructions. And that's why, you know, if you see in the demo booths and you see the Boost platform, this is the kind of thing that it does, is that you don't just have the model decide what it should do. You give it constraints and say, for this process, this is the steps that you need to take, all right? To affect what it senses in the future. That means that really agents, a traditional version of an agent, should be a self-improving model, should be a self-improving system. But you don't want a self-improving system running wild in your business today. You end up suffering from what's known as the paperclip problem. Has anyone come across the paperclip problem? Which is that you tell an AI system to optimize itself for creating paperclips and it wipes out humanity to create the space for more paperclip factories. You know, you can have it over-optimized for the wrong things, and sometimes you don't know what those wrong things are. So in terms of putting it as part of an environment, that's essentially your data in terms of what it's going to connect to, and in the integrations in terms of where it's going to live. Okay, so that's, for example, deploying it into your contact center, giving it access to various line of business systems and various data. And then in pursuit, the pursuit of something, in a conversational sense, is the back and forth dialogue. And this is where generative AI is absolutely great. Dialogue management. Response generation, sounding supernatural, as we've covered, and managing the dialogue, which is getting someone through the conversation. And the reason why it's so important is because conversations don't go from 1 to 2 to 3. They don't go linearly, if I can pronounce that properly. For those that have worked in the NLU space before, when you used to have to map out conversations from A to B to C to D, you've realized that you spend a lot of time optimizing that happy path as it was known. You put it live in front of customers and no one does what you expected them to do. The whole thing ends up like an absolute mess. And then you're chasing your tail all the time because you're like, well, how do I optimize this thing? It's live now. So it's a total nightmare because people don't go from A to B to C. They diverge, the sequences expand, and they go all over the place. Generative AI is brilliant at managing that kind of thing. So the things that you want to have in place that work today to make sure that these things do what you need them to do is that you have to give them explicit instructions, all right? This is the process. These are the steps you need to follow. This is what I want you to do. You give them a specific goal. This is your task. This is what you need to accomplish. This customer, when they come into this agent, they need to change their address. Your goal is to have a successful change of address process by using this API and getting a successful response from it, for example. And then your data and integrations are the things that thread the whole thing together. Right? If anyone's talking about AI and they're not talking about your data requirements, I would argue that they don't really know what they're talking about. The data and integrations is absolutely fundamental to what you do. And then, where the AI can really play a role in terms of where it works is that classification I mentioned earlier on. Basic level, high level classification, really, really, really good at. You're still going to need some disambiguation, but we've covered how you can solve that in your prompting. Dialogue management is essentially the holy grail for generative AI, I think, at least from a conversational management perspective. Response generation, producing those human-like responses. Remember, we saw that the value or the benefits of generative AI is that they can sound really human, really natural. Entity extraction and question answering, that's essentially part of dialogue management and response generation. It's part of having the interaction, taking data out of the conversation that you need for your APIs and answering questions. Retrieval augmented generation is an absolute lifesaver for conversational applications. And then tool calling, creating the code and stuff like that you need to use the tools. And then finally, analytics and testing. With a probability-based solution, you kind of have to use probability-based technologies to analyze them because they're very unpredictable. And so for me, this is the recipe for success when it comes to creating and deploying enterprise AI agents. And this is the kind of stuff that, as we said, you'll see from Boost in the booths outside, and you'll hear from Boost customers over the next few hours in terms of how they're doing this kind of stuff at scale and in production. So hopefully that was useful. Hopefully we have smashed a few of those illusions, brought a little bit of clarity, and I'll be around for the rest of the day if you have any questions or anything like that. All right? Thank you very much.